Good evening, children. Good evening, children. Online students, good evening.
Good evening, ma'am.
Good evening.
Good evening, children. Have you all completed the assignment I gave you in the last class? You can see the questions on the screen. All right. No response. So let's see the answers to the homework questions now. This is the first one, right? 3a plus 7 into 3a plus 7, right? Quickly. Right? Yeah. All right. So how do we find this product? 3a plus 7 into 3a plus 7. So this can be written as 3a plus 7 the whole square. And it looks like a plus b the whole square. Or you can use x plus y the whole square. Because it's already a in the question, right? So you can treat it as x plus y the whole square, which is x squared plus 2xy plus y squared. So on comparing, what is x? 3a. And what's y? It's 7, right? So 3a plus 7, the whole square is equal to x squared plus 2 into x into y plus y squared. Correct? So 3a 7, 2 into 3a into 7, which is 9a squared plus 42a plus 49. Those of you who have completed the homework, please check. Others, take a picture. I'll share the pictures with you on WhatsApp. Those of you here. Not done the homework, Yarni? How many of you online have completed the assignment? Nobody. Okay. The next one, minus b plus c into minus b plus c. Minus b plus c into minus b plus c, which is minus b plus c the whole square. Because minus b plus c is multiplied with itself. So minus b plus c the whole square. So this is like x plus y the whole square, which is x squared plus 2xy plus y squared, wherein x is minus b and y is c. X is minus b and y is c. So the question minus b plus c, the whole square is equal to, you need to write x square plus 2 into x into y plus y square. So x minus b, y it's c. Then 2 into minus b into c, which is b square. Because minus b into minus b is minus into minus is plus. Minus into minus is plus, so b square. And then 2 into b into c is 2bc, but minus you see there. So minus 2bc plus c square. Plus c square. X by 4 plus 3y by 4. X by 4 plus 3y by 4 into x by 4 plus 3y by 4. So this is nothing but x by 4 plus 3y by 4 the whole square. So now this is a plus b. This is of the form a plus b the whole square, which is a squared plus 2ab plus b squared, where a is x by 4 and b is 3y by 4. So the question x by 4 plus 3y by 4, the whole square is equal to a squared plus 2 into a into b plus b squared. where A is x by 4, B is 3y by 4, and 2 into A into B. Now, x by 4 into x by 4. X square by 16. Plus, you can simplify. 2 ones are 2 twos are. You can cancel. 2 ones are 2 twos are. So when you multiply the numerators, you get 1 into x into 3y. So 3xy. 3xy. Multiply the terms in the numerator, 3xy, divided by 2 into 4, 8. So 3xy by 8 plus 3y by 4 into 3y by 4. 3y into 3y, 9y square by 4 into 4, 16. You should square everything. 3 into 3, 9. Y into y square. 4 into 4, 16. You don't have to take the LCM and all that. Just leave it like this. Don't take the LCM and try to do anything. Just leave it like this. Yes or no? So now this is for somebody online. Answer this: 4 by 3 x square plus 3. 4 by 3 x square plus 3 into 4 by 3 x square plus 3. Yes, Aishwarya. Fast. So this is of the form. Are you there, Aishwarya?
Can I answer?
Yeah.
16 upon 9 x cube plus 9 plus x 8x
No, I
square.
want the steps. Yeah, okay, fine. You've completed the homework, so you're giving me the final answer. Please tell me the steps, Aishwarya. Anintika.
Yes, ma'am. So in brackets 4 by 3 x square plus 3.
No, help me complete this. No. 1 minute. 1 minute.
A square plus 2ab plus b square. A is 4 by 3 x square. And B is 3. So 4 by x square plus 3, yes. Then after that 4 by 3 x square in brackets.
So I'll just use empty brackets first. So first we'll have to write a square, right?
Yeah, a square
then
plus
2 into a into
a
b
into b plus b square.
B square. Yeah, so what is a?
4 by 3 x square.
Okay, then b?
3.
Yeah, then 2 into?
4 by 3 x square into 3.
Very good. Okay. Now can we simplify the middle
we
bracket?
can cut the 3 and 3.
Very good. Then?
So 4 by 3 x raised to the power 4 plus.
No, darling. No. 4 by 3 x square into 4 by 3 x square. What is 4 by 3 x square? The whole square. It is 4 by 3 x square into 4 by 3 x square. So what's the result?
16 by 9.
Yeah, you're right.
X raised to the power 4.
Yeah, correct. Plus?
Yeah, then plus 9x, x 8x square plus
Correct.
9.
Very good. First time. So we should square every term inside the bracket. Everything inside the bracket should be squared.
I got the right answer, but I said wrong.
So every term, everything inside the bracket should be squared. So 4 by 3 x square. 4 by 3 x square, the whole square is 4 by 3 x square into 4 by 3 x square. So 4 by 3 into 4 by 3 is 16 by 9. X square into x square is x to the power 4. Yeah, thank you, Anantika. Somebody else here? 0.3x, 0.4y. 0.3x, 0.4y into 0.3x plus 0.4y. So is equal to, first step is equal to, no, is equal to 0.3x plus 0.4 by the whole square, correct? Yeah. So identity a plus b whole square is equal to a square plus 2ab plus b square. So see, this was your assignment so that you write it 5 times. You write the identity 5 times and you get used to it. Now I am doing your assignment. I was only supposed to show the final answer on the screen. Okay, so what is A? 0.3x and B? 0.4y. So 0.3x plus 0.4y. The whole square is equal to 0.4y, and here 2 into 0.3x into 0.4y. Now we'll have to be careful. 0.3 into 0.3. 0.3 into 0.3. 3 3s are 9. Okay, now after the decimal point, there should be 2 digits because 1 here, 1 here. So totally 2. After the decimal point, there should be 2 digits. Because here there's 1 digit after the decimal point. Here there's 1 digit after the decimal point. So the product should have 2 digits after the decimal point. So it should be 0.09. 0.09. So 2 digits. 0.09 x square plus now here 0.4 into 0.4. 4 4s are 16. 1 plus 1, 2. So 0.16. In 0.16, yeah, see, there are 2 digits after the decimal point. Because 4 4s are 16, 4 4s are 16, and 0.16. So after the decimal point, there are 2 digits. So 0.16 y square. And here, how do you multiply? 2 into 3 is 6. 6 4s are 24. Correct? 2 3s are 6. 6 4s are 24. So write 24 xy, 24 xy. And then again in the product, there should be 2 digits after the decimal point because 0.3 and 0.4. So 1 plus 1, 2. It will be 0.24 xy. You're not able to see this screen? Just try to adjust accordingly. 0.2. Yeah. Maybe you can just push the table a little. You're fine now? Yes. 2 3s are 6. 6 4s are 24. 24 xy. And here in 0.3, 1 digit after the decimal point. In 0.4, again 1 digit after the decimal point. So 1 plus 1, 2 digits after the decimal point. So 0.24 xy. See, how many of you have completed the homework? Raise your hand, online students. It's okay. It's fine if you have not done it because I'm feeling so odd working at, like you're supposed to think, you're supposed to practice it. I want to just show you the final answer. Because I'm just taking your time. See, today in this class, we could do something else, like doing the homework will take half the time. Only 2 of you have completed. Here, how many of you finished? You finished all. Last 4 sums you're still to do. Not, you also haven't. Can we, yeah, so, okay, Aishwarya has finished, okay. So, good, Anintika and Surya, but since the others have not finished, can we push this discussion to the next class? So that they also finish, the others online also finish. So that it's easy for me, like I just show the final answer, you can check and you can just get your doubts clarified. So I'll just stop here. I'm not going ahead with the other 2 slides. So I think we have 8 plus 4 plus 4, 8 more questions as homework. So we'll do that. We'll see the answers in the next class. Now, the other concept immediately connected to algebraic expressions and identities is factorization. The concept that follows algebraic expressions and identities is factorization. But in the textbook, it is, you have a few more chapters between these two chapters. Between algebraic expressions and identities and factorization, we have a few more chapters in the textbook. But I always do it. Factorization follows algebraic expressions and identities in my classroom. Because here also we have to use identities. You will see how. Okay. So I actually call algebraic expressions, identities, and factorization one chapter. Algebraic expressions, identities, and factorization is one chapter like. Okay. Fine. So factorization is basically breaking down an expression and writing it or expressing it as a product of its factors. See, we have done that with numbers in lower classes. If you have to factorize 35, so 35 is 5 into 7. Okay, 35 is 5 into 7. This is how we express 35 as a product of its prime factors. This is how we express 35 as a product of its prime factors. Factorize 35. So factorize 35 means we write 35 as a product. Why product? See, we've used the multiplication symbol. The operation we use is multiplication. So we write 35 as a product of its prime factors. So that is factorization. So factorize 100. Factorize 100. So 100 is equal to 2 into 2 into 5 into 5. So we write 100 as a product of its prime factors. So in algebra, again, you have an expression. You will have to break down or decompose the expression and show it as a product of its factors. Show it as a product of its factors. So you're given an expression. You're given an expression, an algebraic expression. If the heading is factorize that algebraic expression, what you have to do is you will have to write that expression, express that expression as a product of its factors. So that expression is equal to this into this into this into this is factorization. Okay. So we'll start with the very elementary one. I'll just work a bunch of questions and then you can take it down. Okay. Okay, factorize the following expressions. The first one, 4x plus 8y. 4x plus 8y. Okay. Now, what is common between the terms 4x and 8y? What's common between the terms? See, this one is a binomial. There are two terms. 4x is the first term and then 8y is the second term. There are two terms. It's a binomial. Now, what is common between 4x and 8y? What is common? 4. What is common between 4x and 8y? What is 4x? 4 into x.
Ma'am, there are multiples of 2.
Yeah, what is 8y? 8y is 2 into 4 into y, right? Okay, 1 minute. 1 minute. So 4x can be written as 2 into 2 into x. And 8y can be written as 2 into 2 into 2 into y. So this you can put in your mind. Now, when I say what is common, I'm expecting the HCF of the two terms. What is the HCF of the two terms? So how do you find the HCF here? 2 is common. 2 is common. So the HCF of 4x and 8y is equal to 2 into 2, 4. 2 into 2, 4. Because there's nothing else common, right? You have circled whatever is common. So from 2 2's 1 2, and from these 2 2's another 2. So 2 into 2, 4 is a HCF. So see what is common between, supposing we have 3x squared and 6x cubed. We have 3x squared and 6x cubed. So 3x squared is 3 into x into x. 6x cubed is 2 into 3, 6 into x into x into x. So what will be the HCF of 3x squared and 6x cubed? What will be the HCF? 3 is common, 3 common, and then x is common, another x is common. So 3 into x, that is 3x squared is common, right? Yeah, yeah. So 4x and 8y. The HCF of 4x and 8y is 4. Open bracket. Take out the HCF, open a bracket. Now 4 into what will give you 4x? 4 into x is 4x. Plus 4 into what is 8y, the second term. 4 2's are 8y. Now see, 4 into x is 4x, the first term. 4 into 2y is, or 4 into plus 2y is plus 8y, the second term. Let me do it again. The first step is to take out the HCF. Here there are two terms, 4x and 8y. The HCF of 4x and 8y is 4 because there's nothing common between the literals x and y. X and y are the literals. In the first term, we have x. In the second term, we have y. There's nothing common between x and y. So there should be, we'll have to check if there's something common between the numbers 4 and 8. What is the HCF of 4 and 8? 4. Yeah, that's what is common. Open a bracket. 4 into what will give you the first term 4x? 4 into x will give you the first term 4x. Plus 4 into what will give you the second term 8y. 4 into 2 is 8 and y. So here we have written 4x plus 8y as the product of 4 and x plus 2y. See, we've written it as a product. 4 into x plus 2y. Factorize means writing the expression as the product of its factors. So you can see the answer. It is 4 into x plus 2y. X plus 2y is one expression. 4 is the other one. And the connecting sign is multiplication. 4 into x plus 2y. So we have expressed 4x plus 8y as the product of its factors, which means we have factorized the given expression. Yeah. Try this one. How many terms? No, orally. How many terms, children? How many terms are there in the expression? Why no response from the online students? 2. 2 terms. Good, thank you. So there are 2 terms, right? Now, let's take the numbers first. 7 and 14. What is the HCF of 7 and 14? 7. 7. Okay. Then, what is the HCF of x square and x? What is common between x square and x? In x square, there are 2 x's. In x, there's only 1 x. So what is common? 1 x is common. In x square, there are 2 x's, x into x. In x, there's only 1 x. So 1 x is common, x. And then in y and y square, y is 1 y. Y square is y into y. So what is common? 1 y is common. 2 y's are not common. Because in 1, there is only 1 y. So 2 y's are not common. Only 1 y is common. So 7xy is the common factor, the HCF. So you can do it like this in your mind. You don't have to actually work like this. I'll put again for you. There are 2 terms. The given expression is a binomial because there are 2 terms. Now let's take the numbers first. 7 and 14. What is the HCF of 7 and 14? 7. So you need to first write the expression which you're factorizing. So write the expression, put an equal to sign, and then HCF of 7 and 14 is 7. Then x square and x is x. Y and y square is y. You can remember like this. HCF will be the one with the least power. See it. I'm sorry to switch, but I just want to say something. Supposing you have x to the power 9 and x to the power 10. The HCF of x to the power 9 and x to the power 10 is the one with the least power, x to the power 9. But the LCM of x to the power 9 and x to the power 10 is the one with the greatest power, which is x to the power 10. We have two expressions, x to the power 9 and x to the power 10. Now we are interested in finding their LCM and HCF. Both the literals are x. Both are x. The one with the least power will be the HCF. The one with the highest power will be the LCM. Now you can extend it to this. So now look at this one. Supposing you have 5 x to the power 4, y to the power 3, and say 20x y squared. All right. So what will be the HCF of 5x to the power 4 y cubed and 20xy squared? What is the HCF of 5 and 20? 5. The highest common factor. HCF of 5 and 20 is 5. X to the power 4 and x, least power. Which is the least power? X. Y cubed and y square?
Y cubed.
Least power. Y square. This is the HCF. HCF take the least power. For LCM, the LCM of 5x to the power 4 y cubed and 20xy square. The LCM will be, what is the LCM of 5 and 20? 20. Then x to the power 4 and x, the highest power, x power 4. Y cubed and y square, the highest power, y cubed, that's all. I'll tell you if one term does not have a z in it, the other one has a z, I'll tell you, we'll come to that. Is this understood? HCF, least power. LCM, greatest power. Supposing you have to find the HCF, x cubed, y cubed, z cubed, and x to the power 4, y, no, that's it. So now what will be the HCF of x cubed, y cubed, z cubed, and x to the power 4, y? What will be the HCF? So x cubed, x to the power 4, x cubed, y cubed, y, the one with the least power. Now, highest common factor, see HCF common factor. Now, is z, do you have the literal z in the other one, the other term? No, just leave it. For HCF, the literal should be present in both the terms. The literal z cubed or the literal z is in the first term. It's not in the second term. Then just ignore it. Just ignore it. Because there's z cubed here, but there's no z literal in the other one. Just leave it. Or if you're like not, like comfortable, why is it like that? You can just treat it as z to the power 0. You can just treat it as z to the power 0 because no, but don't write all this and complicate. I'm just telling you because anything to the power 0 is 1. Anything to the power 0 is 1. So it's like x to the power 4, y, z to the power 0. Now, which is the least power? Z to the power 0 is the least power, right? So you can write z to the power 0. That's the least power. So that's nothing but 1. Z to the power 0 is 1. So it's as good as not writing it. So x cubed, x to the power 4, least power, x cubed. Y cubed, y, least power, y. Z is not present in both, ignore. That's a HCF. For LCM, greatest power, x to the power 4, y cubed. Now see, now this is z to the power 0. There it is z cubed. So which is the highest power? Z cubed. So z cubed will come here. In HCF, it's actually comparing z cubed and there is no z in the other one. So it's like z to the power 0. So the least power is z to the power 0. And if you write it also, it is 1. So we ignore. When a term does not have a literal, now this z was not there in the first one, right? I don't want you to write this, but I'll just show you because see it. It's like this. You're trying to show a literal which is not there. X to the power 4, y. There is no z, but you can write the z to the power 0 because z to the power 0 is 1. So which means it is x to the power 4, y only. Now here also you can write x to the power 4, y and z to the power 0. So use the same, idea. Least power. So x cubed, y, z to the power 0. So anything to the power 0 is 1, no? So it's nothing but, this is nothing but x cubed, y. Now LCM is highest power. So x to the power 4, y to the power 3, z to the power 3. Correct? Highest power. So this is the LCM. Online students? Any questions? Get that,
Yes,
online
ma'am.
students?
Clear, ma'am.
All right.
Yes, ma'am.
All right, children. Let's begin with this one. So the name of the chapter, factorization. Give the heading factorization and take this as the first question. Work these 3. I'll give you 2 more as a test. Let's see how you can apply this understanding there. Factorization. Give the heading factorization. Find the HCF and LCM of the following. Take down these 3 in your notebook. 4 and 5 test. I'll just get back, children. Yeah. So try this one now. Find the HCF and LCM of. Yeah. Done? Yes, Shiva. HCF? Tell me literals. What? X. No, louder. Oh, give me a book. X is correct. Y square is also correct. The first one does not have Z, right? First one. That means it is Z to the power 0. So which is the smallest power? Z to the power 0. Yeah, but you have written Z to the power 4. That means you should not write it. Z to the power 0 is 1. You can write that. Now, one more thing is, what is the HCF of the numbers 25, 30, and 40? Oh, what is the HCF of 25, 30, and 40, children? Yeah, online students. HCF of 25, 30, and 40 is? I don't understand. No response means what? You don't know how to find the HCF, children?
It's done.
Yeah. Who's this with the name class 7? Oh, here is it? You people are in that name. Is it class 7? Okay, okay. All right. Yeah. Yeah, what's a HCF of 25, 30, and 40? I'm not getting any response. 5. HCF is 5. HCF is 5. And see, HCF, you have to think about it. I'm not going to tell you how to find the HCF now. And then among X, Y, and Z, they're least powers. So X, then Y squared. And Z, see, we don't have Z in the first one. So it is Z to the power 0. We do not have Z in the first one, which means there is Z to the power 0. So the least power is Z to the power 0, which is 1. So don't write it. Then the next one, what is the LCM of 25, 30, and 40? What's the LCM of 25, 30, and 40?
Mom, I have a doubt in the HCF thing. We include X, but in 40 y square z to the power 5, there's no X.
Oh, I didn't notice that. Oh, thank you. Aishwarya, thank you so much. Oh my God, I didn't notice that. Okay, let me do it for myself again. So 25, 30, and 40, I'm coming back. I made a mistake with the HCF. I didn't notice that X missing in 40 in the third term. The HCF of the numbers 25, 30, and 40 is 5. And in the first term, it is X squared. In the second term, it is X. In the third term, X is missing. Meaning there's no X in the third term. So it is X to the power 0. So there is no X also. Thank you so much for that, Aishwarya. I was blind, like, yeah. In the first term, children, we have X squared. The second one, we have X. The third one, we don't have X, which means it's X to the power 0. So which is 1. Don't write it. See, if you want to write X to the power 0, but it's 1. X to the power 0 is 1. So I don't want you to get used to writing that. Then between the y's, y squared, y cubed, y squared. So y squared. And between the z's, the first term does not have a z. Does not have a z. That means z to the power 0. Then z to the power 4, z to the power 5. So z to the power 0, which is 1. Don't write it. 5y squared. 5y squared is the HCF. Yeah, what's the LCM of 25, 30, and 40?
Mom, I got 600.
600, huh? 25, 30, and 40. 25, 30, and 40. Okay, 30 and 40. So you should know this method. 2, 25, 15, 20. 2, 25, 15, 10. 2, 25, 15, 5. Then you can divide by 3. So I'm using 3, 3, 25, 5, 5, 5, 5, 1, 1, 5, 1, 1, 1. Now the product, 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 into 25, 24 into 25, which is 600. 600 is the LCM. 600 is the LCM. So 600. Now the greatest powers. The greatest power. X squared, x to the power 0. X squared, x and x to the power 0. So x squared. Y squared, y cubed, y squared. So y cubed. Z to the power 0, z to the power 4, z to the power 5. Z to the power 5. This is the HCF, sorry, LCM. All right, children. One more. Yeah, what's the HCF of 20, 40, and 60? Sorry. What is the HCF of 20, 40, and 60? Good answer? Yeah, 20. Okay, let's see. Online students, HCF of 20, 40, 60? No, please let me know if. No, 1 minute. Am I audible, children? Is there any problem with the voice from my end? Okay, please respond, children. Yeah. What is the, please answer this question. HCF of 20, 40, and 60?
20.
20. 20. Okay, then it's x square in the first term, x to the power 0 in the second term, and x square in the third term. So which is the least power? X to the power 0. 0. So ignore. X to the power 0 is 1. So just leave it. Then it's y square in the first term, y square in the second term, y to the power 0 in the third term.
And y to the power of
Y to the power 0.
Y to the power 0, which is 1. So leave it. Then z. It is z to the power 0 in the first term, z square in the second term, z square in the third term.
Z to the power 0.
Z to the power 0. So the HCF is only 20. The HCF is only 20. The HCF of these three terms is 20. Now coming to the LCM. What is the LCM of 20, 40, and 60?
Mom, I got 120.
Yeah, 120. It's 120. LCM is 120. Now it's the highest powers. With the literals, it's the highest power. So x squared, x power 0, x squared. Which is the highest power? X squared. Y squared, y squared, y to the power 0. Y squared. And it is z to the power 0. Z squared, z squared.
Z squared.
Z squared. So now some of us have trouble with finding the HCF and LCM of numbers. Now for expressions we have understood. Now we have forgotten how to find the LCM, HCF of numbers, 2 or 3 given numbers. I really don't know. Yeah, you have to recall, children. See, this is the method. I'll just tell you maybe for these 3 numbers how HCF works. Now for LCM, you can divide. For LCM, it is write the 3 numbers. Okay, let me be a little more good. I'll just do it for these 3 numbers, 25, 30, and 40. Now I'll tell you the difference in finding the HCF and LCM. When you're finding the HCF, whatever prime factor you use here should be whatever prime factor you use here, all these 3 numbers must be divisible by that prime factor. Okay, so whatever prime factor you write here, all these 3 numbers must be divisible by this number which you're going to write here. So you cannot write 2. You cannot write 2 because 25 is not divisible by 2. You cannot write 3. You can write 5. You cannot write 2 because 25 is not divisible by 2. We are finding HCF. So 5. All the 3 numbers are divisible by 5. So 5 5s are 5 6 are 5 8s are. Again, are all these 3 numbers divisible by the same prime number? No. Further, you cannot divide these numbers by the same prime number because 6 and 8 are divisible by 2, but not 5. 5 is divisible by 5, but not the others. So which means all these 3 numbers are not divisible by the same prime number, which means it ends here. So the HCF of the 3 numbers is 5. While finding the HCF, you need to use the prime number carefully here. All the numbers. So here we are finding the HCF of 3 numbers. All the 3 numbers must be divisible by that prime number which you're going to use. If not, 1 is the HCF. If supposing you can't even start the division, that means the HCF is 1. If you cannot even perform 1 step of division, that means the HCF is 1. Okay, so here for these 3 numbers, the HCF is 5. Now LCM, you can use any prime number, at least 1 number. Now we have 3 numbers. Now 1 of these 3 numbers should be divisible. So you can use 2. You can use 2 because 30 and 40 are divisible by 2. Even if one of the numbers is divisible by 2, you can use 2. But at least 1 number should be divisible. Yeah, so you can use 2. So 25 will come down as 25. This is 15 and this is 20. If it's divisible, divide. If it is not divisible, write the same number. Now, again use 2. Write 25 as it is, 15 as it is, 2, 10 times. Again use 2. 25, 15 and 5. Now don't use 2. None of the numbers are divisible by 2. Then try 3. Yeah, 3. 3, 25 as it is, 3 5s are 15, 5 as it is. Now you can't use 3 because none of them are divisible by 3. So 5. So 5 5s are 5 1s are 5 1s are. You should get 1 1 1. You divide completely. 5 1 1 1. The product of these numbers is the LCM, and that was 600. Yeah, somebody tried to say something. Go ahead.
Mama, I just told the step.
Okay. Yeah, so that's about HCF and LCM children. Is this clear?
Yes, ma'am.
Yeah. Yeah, I'll just wait. If you want to take down this one, please do it. I'll just wait. Done, children. So we'll get back to this one. Yeah, please write down this. The heading is factorize the following expressions now. And take down the first and the second one. No, I don't think I allowed you to write this first. We wrote down, we started here. I started explaining from here, but then we switched to this one, right? Yeah, so now write the heading, factorize the following expressions. Write down the first one and complete the second one. Is this? Yeah, so the HCF is 7xy, yeah. So then in the bracket, 7xy into what is 7x squared by x? plus 7xy into what is 14xy square. So 7 2s are 14, then 2y into y. Yeah. See this again. I want you all to do this in your mind because I can show you a step. See, it's like 7x squared y. You have taken out what common 7xy. No, so you should divide by 7xy. 7 cancels, y by cancels, and this 1x in, so 1x is left, right? So that x comes here. And then divide 14xy square by what you've taken out common 7xy. So 7 1s are 7 2s are x and x cancels. Y and y square is y. So 2y in the bracket. But you can do it one by one like this. See, I'll write this again for you. First step is to, so what we're doing is we are given an expression and we are trying to factorize the expression. Okay, we're trying to factorize the expression. First step is to identify the HCF of the terms in the expression. Now this expression has two terms. The first step is to find the HCF of these two terms. The HCF of 7 and 14 is 7, x square and x, the least power, y and y square. So this is the HCF. After this, 7xy into what will give you 7x square y? X plus 7xy into what will give you the second term 14xy square. How will you get 14? 7 2s are 14. X is already here common. Then y into y is y square. Please check that. Now what's the HCF? 6 x. How x squared? X y. Yeah, x y. Bracket. X into what is x cubed? X square. X into x square is x cubed. Then minus 3 y square. 3y square. Gayatri?
No, I can't get it, ma'am.
You didn't get it?
Yes, ma'am.
Okay, yeah. No problem. We'll do it together. Yeah. So we'll start off with the HCF. Is that understood, Gayatri? HCF of the two terms? Okay, so it is 6xy. Now 6xy into what will give you the first term 6x cubed y.
X square.
X and C. 6 and 6 is there. X
Yes,
x
ma'am.
cubed. So x square.
X
And then
square.
y is there. Y is already. So
Yes,
x
ma'am.
square, right?
Yes, ma'am.
Minus. Now again 6xy into what will give you 18xy cubed. 6 how will it become 18?
3 times.
Yeah, x is already there.
Yes,
Then
ma'am.
y should become y cubed.
Y square.
Y square. So minus 3y square.
Okay, ma'am. Got
Sure
it,
you
ma'am.
understood?
Thank you. Yes,
Okay,
ma'am.
yeah. Okay, very good. Yeah, right on, Chetan.
Ma'am, can you just go to the before slide for a minute? I'll just take a picture.
Yeah. But why aren't you writing now?
Yes, ma'am, I am in the last step, but then I need to make you wait till I finish.
No. I will do it. Yes. It's completed.
Okay, ma'am, 1 second. Yes, ma'am, done.
Okay, good. Let's write it below here. (16 and 24 HCF. HCF of 16 and 24. HCF of 16 and 24 class.
Mommy.
8 minus 8 and m square and m cubed. M square. Now minus 8m square into what will give you the first term minus 16m square. Again minus 8m square into what will give you the square. So 8m square into what will give you the second term 24m cube. This is what you'll have to do. Minus 8m square is common, right? So that minus 8m square into what will give you the first term minus 16m square. And again minus m square minus 8m square into what will give you 24m cube. That's all. So first one, what is the answer of the first blank? 2. 2. That's all. That's 2. Correct. Then for the second one, minus 3 m. Done. All right. So this method is factorizing by taking out the HCF. Factorizing by taking out the HCF or the HCF method. Okay. Sleepy. Okay, so HCF method. Now the next one is factorizing by grouping. Okay. Factorized by rearranging or grouping also it's one. Rearranging. So there are 4 terms, right? So what we do? We group the first 2 terms and the last 2 terms. Okay. Now, in the same way, you take out the HCF, right? Use the same procedure here, only for the first 2 terms. Use this method. Use this method only for the first 2 terms. So what is common between x square and xy? HCF of x square and xy? X, open bracket. This one, exactly what we did here. Same thing, do it for the first 2 terms. X. Now x into what is the first term x square? X. Then x into what is the second term xy plus xy? Y. Plus y. Plus y. Now, in the same way, what is now write the sign, put the sign as it is. See, if we are done till here. Now, after this follows a plus sign. So take the same sign plus. Now, what is common between 8x and 8y? 8. Because x and y, there's nothing common. 8. Open bracket. Same thing. 8 into what will give you 8x? X. Plus y. Because 8 into x is 8x. 8 into y is 8y. Close the bracket. Now, observe carefully that between this and this, there is x plus y common. There's x plus y in the first term and x plus y in the second term also. So take out the common factor x plus y. X plus y. Now in the second bracket, just collect these 2 and write it. Collect these 2, x plus 8. Write that common thing once, x plus y, write it once. And then collect this x plus 8 and write it in the other bracket. I'll tell you the reason for that in the next class, children. See, I can tell you now, but don't get confused, that's all. See here. The reason is, again, we take out the HCF. Again, we're taking out the HCF between this term and this term. Now, what is common between this term and this term? X plus y is common. X plus y is common. Take it out. And now x plus y into what will give you the first term? X plus y into what will give you the first term? X. Then plus x plus y into what will give you the second term? X plus y into 8. So in simple words, whatever is common, x plus y, write it once. And then gather this one, x plus 8, and write it in the other bracket.
Yes, ma'am. Understood, ma'am.
Yeah.
Ma'am, if it is like plus 8 and minus 8 means we can cancel, ma'am.
If it is?
Plus 8 and minus 8 means we can cancel off.
No. See, you're changing the question and asking me, is it?
Yes, ma'am.
No. See, don't make changes in this situation. We'll see different situations.
Okay,
We'll see different situations. Yeah. Don't get this. This understood?
Okay, ma'am.
Yeah. Why don't you? Next one. Yeah, it should be. You don't have to. You can just group it like this because you can see 4 into 4 is 16 and 3 into 4 is 12. 4 into 4 16, 3 into 4 12. So you can just group it in the same order. Now, what is the HCF of the first two terms? The idea is the same. There are 4 terms. Group the first 2 terms and the last 2 terms. And then proceed like this. HCF method. What is the HCF of 4x square and 16xy? So before that, what is the HCF of 4 and 16? 4. The HCF of 4 and 16 is 4. X square and x. Least power x. And there's y here, but there's no y there. It's like y to the power 0. So just ignore it. Now, 4x into what will give you the first term 4x square? X. Again, 4x into what will give you the second term minus 16xy? Minus 4. Minus 4? Y. Minus 4y. Minus 4y. Close the bracket. Now we are here. We finished the first 2 terms. We're here. The sign minus. Put that sign. Put the same sign. Minus. After you're done with the first 2 terms, what follows is the minus sign. Take that sign here. Now, what are the HCF of 3x and 12y? 3 and 12 is 3. 3 and 12 is 3. XY, nothing is common. Sorry. So now 3 into what, minus 3. Minus 3 into what will give you the first term minus 3x. See, we have taken out minus 3 common, but the third term is minus 3x.
X.
Minus 3x is the third term. We have taken out minus 3 common. Minus 3 is common. Minus 3 into what will give you the third term minus 3x. Somebody said that? X.
Yes, this is Aishwarya. I said X.
Yeah, correct. Now again, minus 3 into what will give you the fourth term, 12y. Minus 4. Yeah, minus, because minus into minus plus, 3 4s are 12y, minus 4y. So you will see that you will always get the same terms in the bracket, x minus 4y, x minus 4y. That's very important. If you don't get the same terms in the bracket, you're wrong somewhere. So now write x minus 4y, that common thing once, and gather the remaining to 4x minus 3 in the other bracket. Yeah, right on, children. Done, children? Next one. Yeah. So sometimes you'll have to rearrange. Okay. So now when you look at this one, between Z and 6, see now again, I cannot, I can just tell you what else you can do. But where what is applicable comes only by practice. We can, understand the different ways of proceeding with factorizing the given expression. But when to do what, that comes only by practice. So now here you have to rearrange the terms. Now, if you ask the question, how do you know that? That you will also know by practice. You can also find out that by practice. Okay, but what I can tell you is, now supposing you don't rearrange, you group it as it is. Okay, we'll do that first. So normally we just start off in the order the terms are given, right? We go like this. So what's common between Z and 6? Nothing. So 1 is common. 1. So then you'll have Z minus 6 in the bracket as it is. Then we need to put the sign minus. We need to put the sign minus. And then xy, xy. So xy is common. And the bracket will get 6. Then minus xy into what is minus xy into what is xyz? Minus z. Minus z. Here. Till here is fine. There's nothing common between z and 6. There's nothing common. So 1 is HCF. So in the bracket, 1 into z is z. 1 into z is z. 1 into minus 6 is minus 6. See, when you multiply, you should get these terms, right? You must get these terms. What are you listening? Okay. Now, one bracket z minus 6. Now between the, now I said we stopped here. We need to write the sign as it is. After the second term, whatever sign is there, you should put it here. 1, 2. After the second term, what is the sign minus? Put it as it is here. Now, what is the HCF of 6 xy and xyz? Xy, xy. Now, what should we write in the bracket? Xy into what will give you the third term minus 6 xy. Xy which is common, sorry, minus xy which is common. Please take it with the sign. Minus xy which is common into what will give you the third term minus 6 xy. 6. Correct? Yeah. Now minus xy into what will give you the fourth term xyz. Minus z.
Minus z.
Are you all getting this?
Yes, ma'am.
Okay. So minus z. Now what do you have in the two brackets? Z minus 6, 6 minus z. But if we had rearranged, we would have got the same term z minus 6, z minus 6. Okay, we'll just wait. Okay, now I just want to do it again so that, you know, it's clear to all of you. I'm going to repeat this. Just going to repeat this. So write out the expression given. Write out the expression given. We normally group the first two terms and the last two terms. So let's do that. Now we start off with the HCF of the first two terms, which is 1, open bracket, 1 into so 1 into what will give you the first term z? 1 into what will give you the first term z is z. So z here. Then again, 1 into what will give you the second term minus 6. So minus 6 it is. After the second term, whatever sign is there, put it as it is. Now again the HCF of 6xy and xyz, which is xy. Open bracket. Now this minus xy, which is common, into what will give you the third term minus 6xy. Aishwarya, please disable your mic. Yeah. So minus xy into what will give you the third term minus 6xy.
Mom, 6.
6, just 6. That means, correct? And again, minus xy into what will give you the last term xyz.
Minus Z.
Minus Z. Because minus into minus plus X, Y, Z. Minus into minus plus X, Y, Z. So it's minus Z here. Now, yeah. Now the thing is we need to have the same expression inside the two brackets. But we don't have the same. We have Z minus 6 and Z 6 minus Z. Now we're going to learn something new. You can write A minus B as B minus. Very, very important. You can write A plus B and B plus A both are the same. We know that. A plus B is the same as B plus A. But A minus B is not the same as B minus A. They're not the same. They're different. But A minus B can be written as minus of B minus A. Make a note of this. Very important. Not now, I'll show you. Very important. A minus B is the same as minus of B minus A. B minus A is the same as minus of A minus B. Now to finish the answer, I'll just proceed. Okay, remember this. A minus B can be written as B minus A by taking a minus outside. B minus A can be written as A minus B by taking a minus outside. Now see here, I want to write 1 into Z minus 6. Now the 6 minus Z, I want to write it as Z minus 6. Like A minus B, I want to write it as B minus A. I want to write 6 minus Z as Z minus 6. What should I do? I should take a minus outside. If I take a minus outside, this minus into minus will become plus. I need to take a minus outside. But there's a minus already here. So minus into minus will become plus. Which means what you should do is if you want to write 6 minus Z as Z minus 6, do it and change the sign outside. If it's minus, make it plus. If it's plus, make it minus. Because when you take a minus outside, and okay, it's like taking out a minus sign. Minus into minus will become plus. You will observe that it's like writing the opposite sign. In the earlier step, it is minus xy. Now it becomes plus xy. Why? Because you've written 6 minus z as z minus 6. Now z minus 6 is common. And then gather that 1 plus xy. Or you can write xy plus 1. So these are the two factors of the expression. See, you can see the final result. Factorize, so you'll have to write it as a product of its factors. So the answer is z minus 6 into 1 plus xy. So these are the two factors of the given expression. Z minus 6 into 1 plus xy. So z minus 6 is one factor, 1 plus xy is the other factor of the given expression. Right on this? Try this one. Please complete the third one and try the fourth one, children. I'll just come back. Yeah. I'll just take this question on the next slide, children. Yeah, just read that for me. 28. 21 minus 21y. 21y plus 8x plus 8x squared minus 6xy. All right. So we'll start with grouping like this. The HCF of the first two terms is the numerical one is 7, and for the literals it's nothing. So it's just 7. Open bracket. 7 into what will give you 28x? 7 into 4x. So 4x. Next, 7 into what will give us minus 21y? Minus 3y. Minus 3y. Close the bracket. After the second term, we have a plus sign. So that's what we need to take here. The HCF of the third and the fourth terms is for 8 and 6 is 2. X square and x is x. Ignore y. This is the HCF, open bracket. Now the HCF 2x into what will give us a third term, 8x squared. The HCF 2x into what will give us the third term, 8x squared. 4x. 4x. The HCF 2x into what will give us the last term, minus 6xy. Minus 3y. Minus 3y. So here we see that the expression in the brackets, the two brackets is the same. So just write that once, 4x minus 3y, and gather the term 7 and plus 2x in the other bracket. You can write it as 2x plus 7 or 7 plus 2x. Both are fine. Both are the same. You can even write it as 2x plus 7. 7 plus 2x. Online students?
Yes, ma'am.
Yeah, any questions? Have you all got the same answer?
Yes, ma'am.
And that note, I forgot to ask you to make a note of it. So please make a note of it now. If you haven't. I think you. You had worked it correctly, is it? Yeah, me. Okay, you said you went on somewhere. You didn't get this answer? Dash. Okay, so what had you written there? No, show me. Where was the mistake? I just wrote it. Okay, no, that's okay. But do you have any questions to be answered? Okay. Any questions, online students?
No, ma'am.
Next one. First two terms, last two terms. Quickly, what's the HCF of the first two terms? Louder. No. 8 L. 8L. 8L, open bracket. So 8L into what will give us the first term 16L square? 2L. Then 8L into dash gives us the second term minus 8L. Minus 1. Because 8L is already there. 8L into 1 is 8L. 8L is already there. So 8L into L will become 8L square. 8L into 1 is 8L. Plus into minus minus. With minus 1 here. Then I said whatever sign follows the second term, minus. Write it as it is. Write it as it is. Now again the HCF of the third and the fourth terms. 4 and 2 is 2. L ignore M. Now again minus 2M into what will give us the third term minus 4LM. 2L. Because minus into plus minus 2 to the 4L. So 2L. Again minus 2M, which is common, into what will give us the fourth term 2M. Minus 1. Because 2M. 2M. See, 5 into what is 5? 5 into 1 is 5. 5 into what is minus 5? 5 into minus 1 is minus 5. So 2M. We already have 2M. So 2M into 1 is 2M. But the sign minus into minus is plus. Right? Minus 1. Then we see that the expression, the expressions in the two brackets are the same. So we write it once, 2L minus 1, and then gather the other terms. Now, we have one more step here. Look at the terms in the second bracket. Is there anything common between the two terms there? 8L and 2M. 2 is common, right? 2 is common. 2L minus 1 into 2 is common. So what do you have in the bracket? 4L minus M. So you can put the 2 outside here. 2 into 2L minus 1 into 4L minus M. We have an alternate approach also for this one. I'll just tell you that so that I don't forget to in the next class. Done with this one, all of you? Online students?
Yes, ma'am, done. Ma'am, I need to leave in a couple of minutes. I'm going out for dinner.
Okay, even I'll wind up the session in a few minutes. Yeah, just repeat the question. Yeah, I can see it like that. So we'll just do this in a different way. Yeah. Yeah. So what you can also remember is that if all the terms have something in common, take out the common factor. If all the four terms have something in common, take out the common factor first. Now all these terms have 2 in common. See that? All the four terms have 2 in common. So take it out. All the four terms have 2 in common. All the four terms have 2 in common. Only 2, nothing else. Take it out. So 2 into what is 16L square? 2 into 8L square. 2 into what is minus 8L? Minus 4L. 2 into what is minus 4LM? Minus 2LM. And 2 into what is plus 2M? Plus M. This is the first step. Now let this 2 remain. Yes, sir. Yeah, children. So, okay. So now what happened? Now group the first 2 terms and the last 2 terms. But use a square bracket now. Now, what's the HCF of 8L square and minus 4L? 4L. Open bracket. 4L into 2L. 4L into 2L is 8L square. Minus 1. You know the idea now. Then write the sign that follows the second term. Write it as it is. Minus. M is common between the third and the fourth terms. Open bracket. 2L. So it is 2. And you can see 2L minus 1, 2L minus 1 in the bracket. So 2L minus 1 into 4L minus N. The same thing, what we got here. So remember, when there's something common, when all the 4 terms have something in common, take out that common factor and then group. Yeah. Done, children? All right, children. So that's it for today's session. Thank you so much. Online students can leave the call. Good night.
Thank you, ma'am. Thank you, ma'am.
Thank you, children. Thank you. Good night.